So thank you, Peter, for joining us. Peter is joining us from Zurich today. He is a senior staff engineer of Google. He's also a president at MLCommons, if I've got that correct, Peter. And he's going to speak to us today about all of the great work that MLCommons has been doing, and also how MLCommons has an active interest in federated learning and have been in discussions with Flower on this topic among other organizations. And so I'll hand over to Peter for the talk. Thank you so much for joining us today.
Great. Thank you very much. I want to talk about three topics today. The first topic is to give everyone a little bit of background on the MLCommons Association and how we're trying to build the ML ecosystem. The next thing I'd like to talk about is one of our projects that's closely related to federated learning, the MedPerf Platform. It uses something we call federated evaluation, which we see as a very high potential gateway to encouraging broader adoption of federated learning. And then I want to tell a story about the MLPerf Benchmark, which was the genesis of the MLCommons organization, sort of how we got to this point that I think might have a few interesting parallels to the Flower effort and the state of the federated learning field. So let's jump right in. The MLCommons Association is a nonprofit consortium that aims to make ML better for everyone. We really believe that ML has tremendous potential to broadly benefit society. We think it can be transformative in healthcare. It's a particularly vital area for techniques like federated learning, automotive safety. We kill an amazing number of people on the roads every year, and ML can do better. Information access. As someone who only speaks a little bit of German and lives in a German-speaking country, I have to tell you that machine learning translation is amazing. And I hope it further develops to make sure everyone everywhere can access the information they need. And lastly, in terms of business productivity, I think we're lucky to live in the developed world at the top of a pyramid of productivity. If we want everyone to live the same lifestyle, we need to increase human productivity dramatically, and machine learning has a tremendous potential to do that. But for all that it conjures up images of space stations and Asimov-like robots, it is a young technology and a young industry. We are in the Wright brothers days, the computers that fill room days, not the days of commercial air travel or a highly capable computer in your pocket. We're still in this very young, early stage. And if we want to get out of this stage, we need to work together to develop the ML ecosystem, to go from the Wright brothers to modern airliners. As we develop the ecosystem, ML across the board becomes more capable, less expensive. That broadens its appeal and its reach, and grows its markets and its impact. So in support of this mission, MLCommons brings together a global community, a whole bunch of different tech companies, from big companies to small startups all around the world, academics from a whole bunch of educational institutions, again, all over the globe. And we're all aiming to build this ecosystem. And we see the ecosystem as having at least for MLCommons, three large pillars: benchmarks, ways of measuring things, everything from accuracy to speed, data sets, which are really the raw fuel of ML. ImageNet cost about $300K to build and has arguably created modern ML. Best practices. Right now, we're still everybody does ML their own way. And getting to the point where people do them in more standardized ways, enabling us to have higher interoperability in our infrastructure, is really essential. The web would not be here without HTML. All of this requires research. We're still in that early stage where many of these These pillars involve unanswered fundamental questions. But if we can drive these things forward, we believe it will really accelerate and advance ML innovation. So MLCommons today has a whole bunch of working groups spanning these pillars. Different benchmarks, different data sets, different best practices, different research groups, including one looking into medical ML. And I would like to talk a bit about what that research group is doing, in particular, a project called MedPerf. So MedPerf is a platform for federated evaluation. So why do we need such a thing? Well, we're doing a lot of ML research in medicine, but it's hard to actually transition that to the clinical world right now reliably. ML models that look great in the lab often fail when we try and take them into clinical practice because of different clinical methodologies or different patient populations. So how do you fix that? Well, you need more diverse data. But hospitals, as anyone who's tried to work in this space knows, are reluctant to share data because of legal, regulatory, PR risks, the cost and complexity of data labeling, and the uncertain return of actually going through all of those hoops. So our idea is to create a low activation energy or lower activation energy opportunity to make data indirectly available and further ML and reduce its overall uncertainty. The idea here is to focus on evaluating trained models. So we have somewhere a benchmark owner who creates a benchmark, say, we're going to try and develop models for looking at mammography and recognizing breast cancer. And they recruit in their established circle of trust hospital and medical model developers. The hospitals prepare small shards of representative data. The model developers package their models in a standard way using a container-based but secure best practice MLCommons has developed called MLCube. And then the MedPerf platform distributes those models to the hospitals, where they are tested on the shards of data and then aggregates the results. So for a federated learning crowd, this is pretty simplistic, right? This is a fraction of what you have to do real federated learning, but it is a significant fraction. And it doesn't require the hospitals to feed back weights, which raises their concerns over sharing patient data inadvertently or distributing business value. It requires a lot less labeled data as well. MedPerf has a pretty standard server client design. There's a server where people register their benchmarks and the models and data sets that will participate. The server talks to clients at data owner facilities, sends them models. After helping them prepare the data, the models are executed, results are returned and aggregated. So at the moment, we're taking a very simple command line approach to this. We're building web interfaces actively, and we'll have those up shortly, but we very much believe in the sort of launch and iterate approach. The server lets people register their benchmarks, models, and data. Clients help data owners prepare their data. This is a huge part of any federated approach, is aligning data across multiple facilities so it all works in concert. The MedPerf client also helps with benchmark execution flow, where you want facilities to review models that they're being asked to execute against their representative data, review the results that they produce, and confirm that they're happy sharing those results. We very much believe in making data owners feel as comfortable as possible with this process. We've done a number of pilot experiments, including brain tumor segmentation, pancreas segmentation, surgical workflow recognition. We've tested our client on a number of platforms, both local and cloud-based. And I'm very excited to mention that we will be the platform for the 2022 Federated Tumor Segmentation FETS Challenge, which is a very popular federated learning challenge for assessing training models. Great opportunity to work with these folks. They're doing some really neat stuff. Well, one particular reason that I wanted to mention this project in the context of this summit is that I really do think this is a good gateway that overcomes potentially some of the resistance to FL. There are sort of two conditions that any federated learning approach needs, at least in my opinion. One is a community of trust, people who are willing to work together, who have data and will cooperate. And the other is alignment of that data, so that you can apply the same model in whatever way to all of the data. In order for this to happen, you also have to overcome a lot of costs and risks, legal, regulatory, PR. And you have to label sufficient data, which is hard and expensive, in order to enable whatever you're doing. With federated evaluation, we can establish community of trust and data alignment that leads to later federated learning, but nicely, because the only thing that ever gets shared is the results, not weight updates. And for evaluative purposes, as opposed to training, you need substantially less labeled data. Federated learning has a lower cost and risk profile. Or sorry, excuse me. Federated evaluation has a lower cost and risk profile. So we think this is a good opportunity. People excited, working together, seeing benefits to federated technology with federated evaluation, and then help them grow and transition into federated learning. So to be a little cynical, this is like the gateway drug, we think, for federated learning. So yeah, this is gets people excited before we give them the hard stuff. So if anyone would like to learn more or get involved, it's a MedPerf repo. MedPerf paper is in preprint right now. It's currently in the journal publication process. And we've got a very active working group that would always welcome interested people who are excited about this sort of thing. So having talked a little bit about MLCommons and what MLCommons is, and given MedPerf is a neat example of what MLCommons does, I'd like to talk about MLPerf, which is kind of the original benchmark that started it all for MLCommons, and how we transformed MLPerf from an idea into an industry standard, and then eventually into a organization with a larger mission. I think there's a number of interesting points in this story. So once upon a time, back in 2018, when face-to-face meetings were normal and no one had ever heard of COVID, a simpler time. Some folks at Google dreamed of having an industry standard benchmark for ML, a sort of spec for ML. Spec has done an amazing job of organizing and driving progress for general purpose computing over 30 years. We wanted something like that for ML. I was a new Google engineer at the time and thought this was an interesting project. And so I did the proper thing and wrote up a long design document with some ideas in it and started shopping it around. And I was fortunate enough to find another engineer who'd written a much shorter document suggesting that we needed something like this. And that engineer happened to be David Patterson. If you're going to find a collaborator for your project, it's good when they've won the Turing Award and written the definitive, or one of the definitive books in computer architecture. I highly recommend this as a start for any industry standard effort. But I was able to bring one thing to the project that Dave did not have, and that was an empty calendar. And this proved to be a good combination. We also had a lot of other fellow travelers. We were by no means the only folks interested in doing this. And we had a really talented crowd. And as we started looking around, saying, the first thing you do before you actually put in the time to build your own is you look at what exists. We found several existing ML benchmark suites. There was Fathom, a really diverse suite developed at Harvard. Deep Bench, which looked more at ML primitives, developed by some folks at Baidu, led by Greg D'Amos, and Dawn Bench, something out of Stanford that was very open-ended, but was looking at an interesting metric called time to train. And so at this point, we had two real choices. Well, we could come up with our own better approach and start competing with all these efforts. But we did notice that none of these efforts had really taken off and gained definitive traction. And we really wanted to see an industry standard. So instead of doing that, what we did is we invited them all to a meeting. So on February 8th, we got the principals of these different efforts together in a room, and we said, hey, we'd really like there to be an industry standard benchmark suite. Do you think you'd like to work together and help us create one? And fortunately, we had a bunch of really insightful and genuinely nice people who were excited about that idea. About rather than grinding their project, about seeing if we could do something together to transform the industry. And so we spent a lot of time in meetings over a couple of months arguing about definitions. What does ML benchmark mean? Eventually, for us, we agreed an ML benchmark measures the time it takes to train a model on a data set to a target quality. And this seems like a fairly simple definition, but there were a number of choices here. We had to go into details to reach alignment on our approach. For instance, do you specify the model? Do you say just train whatever you want? That seems to allow maximum innovation. Or do you say it must be this model because we really want to be able to compare our hardware platforms, for instance? We ultimately ended up having two different divisions to handle these different needs. But this specific isn't really important for this story. What is important is that we had a bunch of competing approaches, meeting regularly, trying to establish common definitions so that we could get to the point where we had an industry standard for the field. Eventually, we all produced a straw person doc. So this is, maybe a dozen people meeting regularly. We came up with a doc about what we thought a potential benchmark could look like. And this was a start, but it was far from perfect. But that didn't stop us from sharing it. So we first of all brought together everyone we could think of in the industry and told them we were going to do this. We didn't want to surprise anybody. We wanted to tell people what was in it. And then we announced it at O'Reilly AI in New York in May. And we invited everyone who was interested to come work with us and make this better. Which is good. People liked the idea. The response was very positive, but a lot of them had criticisms. They had concerns about, was this benchmark suite fair? If they hadn't been in the room when we started picking benchmarks, they wanted different benchmarks. They saw technical issues. They had some concerns about having a summary score. There's a very interesting series of debates. These were really good criticisms. We adopted Chatham House rules, so I can't talk about the actual debates in the working groups. But a lot of our debates carried over into our public mailing list. So this is a great debate on whether or not you should have a summary score. You have different benchmarks for vision and speech and so forth, and then you roll those all up and say, this is your system score, or do you just let them stand on their own? And this is a great back and forth between among others, David Patterson and Jonah Albin, a VP at NVIDIA. And it's fantastic, really good points. And ultimately, we ended up changing our approach and dropping the summary score. And as we did this, two important things happened. The first thing was that our definitional document got better. It got clearer. People forced us to clarify the language, clarify the ideas, address things we hadn't addressed. The second critical thing that happened was that our community of owners grew. This is one of our meetings after a few months. I don't have time to do it properly, but a lot of brilliant people who made great contributions here from a wide variety of companies. There's probably people from 20 different companies and universities in this picture. But this community of owners, this feeling like we all had come together and weren't working on our own thing, we were now working on our thing. It took time to achieve, but I think it is tremendously powerful. And when we built this community of people, the consequence was to build a community of orgs. We all sort of brought our organization with us. You know, we think this is exciting. We think our organization should back this. This was the supporting organizations by the time we posted our first set of results. We also built more organized working groups. You know, we evolved from meetings to actual structure. And we did a lot of work. We were fortunate enough to find leaders. This is Victor Bietorf. He led the formation of something called the Submitters Working Group with the realization that, hey, it's great to have a document, but we probably also need some code. And we need to turn that document into some very clear rules. And this is Paulius Misakavicius. Anyway, I still can't do his last name, but Paulius is awesome. And would forgive me. And he led our special topics working group, looking at any question that we had to get off the agenda for submitters because it was too technically deep. How do we benchmark with stochastic convergence? This is a real problem. It's nice to have benchmarks that are deterministic when you're training an ML model, especially something like training a model to play Go. The time it takes to converge is highly variable. We had to figure out how to overcome that. But fortunately enough, we were able to find from this community we built great leaders for our working groups and great participants, engineers, who would bring their ideas and actually do work to move us forward. By the end of that year, we had several teams make benchmark submissions. This is the Google team in literally the last hour before the deadline, still trying to bring their submission together. You can see the countdown on the board, the intense work going on to make it all happen. And on December 12th, we posted our first results. This was a pretty simple set of different systems measured across a different set of benchmarks. It had some limitations. It was sparse. But this was really the first time that something this big and this systematic had appeared in the ML performance community, and was a big deal. So we went out and celebrated. You know, here you can see a typical wild Silicon Valley party, just as depicted in the social network. You know, we went crazy a little bit, and you can see it here because we were pretty excited. So, but we kept working and we kept growing the effort, and we went from training in 2018 to inference in 2019, and then supercomputers and mobile phones in 2020, and the IoT world in 21, and now we're working on storage systems. And along the way, we've been fortunate enough to continue to come up with good definitions, write good straw person documents, build a community, find great working group leaders who are really driven to get things done, and engineers who are willing to contribute and actually make things happen. And we've had, I think, a pretty impressive impact. This shows the change in the longest lasting MLPerf benchmarks over about 3 years. And what you can see here the absolute change from the baseline is around 16x. Now, this is in part because we're learning to scale the benchmarks to larger systems, in part because we're getting better with benchmark optimization for the MLPerf benchmarks, but a lot of it is because we're getting better software stacks. It is amazing how much motivation you can get out of an engineering team because they want to win a benchmark. And all of the major participants in MLPerf have remarked on this, that we have much better software stacks and increasingly better hardware systems because we're all constructively competing to do better. But this was because we were able to get to that critical mass where we could build an industry standard and get everyone working together. Along the way, we were able to leverage that critical mass and create a new organization we call MLCommons, a nonprofit association, to support this and other efforts. MLCommons is what I introduced at the start of this talk. So what did we learn? Just in case anyone on this call happens to be engaged with a early stage ML ecosystem project, 7 morals for ML ecosystem efforts. Critical mass drives success. If I leave you with nothing else, it's always very tempting to do your perfect thing that is better than the other things. But there is nothing like bringing together over half the potential options and getting them on the same page. It creates an amazing snowball that can do things that are very, very hard to do with scattered efforts. In doing this, it does help to recruit a guru or more than one. Find your Dave. We were very lucky to have a Dave. They're an amazing resource, but they can help you assemble that critical mass, but you still have to have the critical mass if you want to do this the easy and high success way. Start with the straw person document. I've used this in working group after working group. Write a document down accepting that it's wrong and focus it on definitions. Just that act of writing something down and putting it in front of the group and saying, here's a set of wrong statements, make them better, does a great job of getting you out of the endless meeting conversation loop and into a forward progress in an organized fashion. Share widely. Share that document with everybody. Arrange meetings, have lunches, get people together for drinks, grow your community of ownership. Don't just advertise your event, make a list of all the people you want and convince them to come, and bribe them with food. A lot of us have been trained as graduate students and that still works well. I highly recommend that as part of a good approach. From that community, look for people who can be strong working group leads. Give them a well-defined mission, a way to judge their success. Find engineers who are excited about that mission. Those people are precious and are the reason that you can build anything. Launch at V05. Don't go for V10. V05 gives everyone room to do it less than perfect, to do something good enough and get it out the door, and leaves others rooms to come in and criticize and contribute without anyone taking it personally. If someone says your V05 system has a problem, you're like, of course, look at the version number. Help me get it to V06. Iterate rapidly. This was actually based on a piece of advice from Dave, who's done this more times than I care to count, and is very wise and worked well for us. Over time, we figured out that having an organization helps. There are certain things that are very hard to do when you're an effort floating in space and on free to use software. Having a backing organization helps. We noticed that there was no organization that was really focused on collective engineering for ML. There were the large collective engineering effort that is Linux Foundation, but they have a very broad mission. There were ML-focused folks like Partnership for AI, but they were more focused on policy. There was nobody who was focused just on engineering for ML from the board down, and that's why we created MLCommons. And since we've done so, which was a lot of work, I'm happy to talk to anybody who wants to try doing this and try and talk them out of it. But we did it, and we've got something that we hope can be a real asset to other people trying to do things like this. We're always happy to talk to projects or folks from projects who would like an organization to support something they're doing in the ML space and want a lot of latitude to continue doing it their way. That is exactly what we wanted, and that's exactly what MLCommons tries to supply. And lastly, and this is critical, I think. One of the things that has made MLCommons and MLPerf successful is that we tried really hard to keep it fun and to celebrate when we succeed. We had a lot of face-to-face events. We're hoping to get back to that soon. We had a lot of cake, a lot of drinks. Part of it is to be honest, and please don't repeat this to your managers, is to make it more fun than everyone's day job. That is a great way to get people to contribute to your open source or open definitional effort. So that concludes my talk. I think I hope that some of the things I said are interesting and useful to the Flower community. I think Flowers is a really great effort, and I and MLCommons would like to do whatever we can to help bring together more people in federated learning and move that space forward.
Thank you, Peter, for the great talk.